now. The session is being recorded. Please be mindful and respectful of the class environment and your fellow students. Anything you say, type, draw will be forever recorded with your name attached to it. Okay, so please conduct yourself in a professional manner. With that being said, you have the ability to chat. So if you want to type a comment or a question, here we go. Did you change the way you're recording the lectures last class? I wasn't able to see the time on your recording, and since CDA, I've been basing the time. I didn't change anything. No, Stephen, I'm not sure. Are you in a different time zone? Is that the problem? No, I haven't changed any of my session settings. So besides typing, you can also, well, it depends. Sometimes I'm recording whatever you see. Sometimes I'm showing you my desktop. Sometimes I'm showing you my my posted files. Okay, so I use a variety of different media inputs. So whatever you see should be recorded, right? Whether it's my desktop or whether it's the files posted. For instance, the message you see there, the session is being recorded. That's a shared file through Blackboard. I also have the ability to share my entire screen. So sometimes you see that, but that should all be recorded, everything. Okay, well, I mean, it should be available. And again, I believe just like during the session, you have control over the zoom factor. I believe you can zoom in and out. I know during the class you have that ability, kind of at the top left. You have view controls. You can zoom in and zoom out. The recorded lectures. I think what Stephen was trying to ask for is if you can share your whole desktop instead of sharing one application at a time. It depends on what I'm doing. Like I said, I use a variety of techniques. Last class was rather difficult to follow because you shared one application at a time. Yeah, okay, I'll give that a try. Okay, let's try that. So I'll share my entire screen and I'll have to cut back and forth. Okay. So last day we talked about the water main. So again, I'll share my screen. So you can see my entire screen now. Is that what you mean? Okay. So is that better? Carl, can you see my CAD file now? You can also see the chat, the chat on the side, right? I have to be able to see the chat. I only have one screen. Okay, so I'll try this technique. Okay, so last day we were discussing the water main layout, and the water main layout is based on this document here. So we looked at the document that is provided through the installation guide. So some of the features related to the water main are here. There's two techniques we discussed. If you remember, we can do a joint deflection technique to mimic a radius, right? So kink the pipe at every joint connection. That's one way of kind of approximating a curve. Or you can bend the actual pipe, okay? So there's bending the barrel and there's deflecting the joint. One of these is not allowed. Did anybody look it up in the standards? Which of these two techniques is not allowed? Did anybody figure that out? Are you allowed to bend the barrel or are you allowed to deflect at the joint? Bending is not allowed. And which document did you get that from, Carl? Where did you figure that out? Halton standards. Okay, very good. So in Halton, if you look at the Halton standards, now at a glance, so you have to look at both standards. Okay, there's the town of Milton, which generally concerns itself with the roads and the storm sewer and the storm management. Okay, sorry, I'm just going to the beginning of the document. So the town of Milton engineering standards really concerns itself with the roads, right? You can see here the roads, lot grading, traffic control, parks, and then drawing, submission, engineering, and so on. These are the different categories that it's concerned with, right? Roads, then all the drawings, and so on. You won't see anything here related directly or in detail for sanitary or water main. Sanitary and water main usually falls under the jurisdiction of the regional government. Okay, so the storm drainage is here with the grading. So you have to go to the Halton standard. Now, when you look at this at a glance, you can actually see where the 3-hole punches are. So at a glance, this is just a scanned document of the hard copy, right? A 3-ring binder, loose leaf paper document. Okay, but once it goes into Adobe as a PDF, you can actually still search the document, believe it or not. So if you type Control F, you'll get the find. And if I type in here barrel, it's going to find the matches, and you'll see right here system layout for sanitary. Right? It says here wastewater. That's the sanitary system or water. Sorry, the water, not the sanitary. You'll see right here it says pipe, barrel, bending, deflection is not allowed. So you can use the joint deflection, right? Maximum allowable pipe joint deflection shall be 70% of the manufacturer's specifications. We'll talk about that in a minute. And then it says you can't barrel bend. So of these two techniques, right? Of these two techniques, this is allowed. This one here, bending the pipe barrel, is not. Although the manufacturer allows it, the regional government does not. So this is the only way to approximate curves. So this is the table you want to concern yourself with right here, bottom right. And what you'll see is, and if you notice in our subdivision, all the pipes surrounding the site we're working on are all 200 millimeter pipes or 8-inch pipe. So we can approximate a 116 meter radius, right? Because we can deflect 3 degrees. Okay, which means at each pipe joint, we can, once we make the joint connection, we can kink the pipe out of line by 3 degrees, right? Or it's a deflection angle of 3 degrees. Okay, now if you use 3 degrees, you can achieve 116 meter radius, an approximate radius. I wouldn't do that. Remember, the standard says, let's go back to Halton, the standard says 70% of the manufacturer specification, so they don't want you to use 3 degrees. So if you take 70% of 3 degrees, 3 times 0.7 is 2.1 or 2 degrees. So instead of 3 degrees, I would use 2 degrees, right? So I would use 2 degrees. So don't use 3 degrees, use 2 degrees. And then this radius will become a little bit bigger, okay? So as long as there's no radius, you know, that's smaller than, if there's a radius that's bigger than 116, then you can joint deflect to approximate the radius, okay? With this 3 degrees, and we're not going to use 3, we're only going to use 2, as it states in the standard, right? Use 70%, so 70% of 3 is roughly 2, it's 2.1, so we'll use 2. We're going to use this angle, this 3 degrees deflection, to then navigate tighter curves without joint deflection, but we will allow the joint deflection. What I'm interested in doing is using these fixtures. You remember 90 degree elbow, right? 90 degree, 45 degree, 22 and a half, and 11 and a quarter. Okay, so these are the joint deflections. What am I talking about? Remember in the corners, let's go back to the drawing. Remember in the corners here, right? I want to go from this direction to this direction. This radius is too small. If you list it, right, as a standard offset of the center line or the edge of the road is going to be too small, 15, nowhere near 116. Okay, so you can't curve the pipe like that. So now I need to change direction from here to here. Okay, you may want to keep the curve just as an idea of where you want to put the pipe, okay, but it can't be curved. So you might want to split the difference. I'm just going to connect this point to this point and move this line approximately here, right? So not right to the edge of the circle, not at the beginning, but somewhere in between, okay? And you won't know where to put this until you finalize the location of the sanitary and the storm sewer. How do you finalize the sanitary and storm sewer? You have to put in the service connections for these 2 lots, and then you can finalize the position of the water main, okay? We'll talk more about that when we do service connections in a little bit. So if we look at the angle, the deflection angle, okay? If we look at the deflection angle, right, you can see even by eye it's not 90 degrees. So if I extend, say, to the street line this pipe, and I extend to that pipe, this angle between here and here, right in here, is the deflection angle. So if I type in DIM and then ANG for angle, dimension the angle, if I click here and here, it tells me what the angle is. This is 96 degrees. Almost 90, but not quite. Here's what we're going to do. We're going to take advantage of, okay, and this is a little bit of knowledge regarding the joint deflection. Let's go back to the joint deflection, right? We can kink the pipe a little bit. We can kink it a little bit. And we can kink it, the manufacturer says 3 degrees, right? It says 3 degrees right here, but I'm going to use 2 degrees. So at each joint, I can wiggle the pipe by about 2 degrees. Okay, so what does that look like? Let me draw something. It might make more sense. Okay, everybody see my hand? Can you see me there? Just give me a quick yes, somebody. Okay, so here are those fixtures. Suppose we had a water main coming down here and then turning here at exactly, this is the deflection angle. Let's say the turn was exactly 90 degrees, right? 90 degrees. Well, then I could use a 90-degree elbow and I'm done. Okay, that's one way. I could split the difference. I can do this and have a 45-degree bend here and a 45-degree bend here. Okay, and then I can get rid of this. So here's another way. Right? And then remember, the deflection angle is the change in direction. Extend, there's the change in direction. Extend, there's the change in direction. So I can use 2 45s. Okay? Again, keep in mind the relationship between the two original lines is 90 degrees. Instead of 2 45s, I can split the difference again. Here and here. And I can have 1, 2, 3, 4. 45 divided by 2 is 22.5 degrees. 22.5 degrees, 22.5 degrees, 22.5 degrees. So I can get rid of the 2 45s and put in 4 11.5s and so on. Okay. If you do that, you can start to see the pipe kind of starts to look like a curve. Okay. So you can use the defined elbows to navigate these changes in direction. Okay, again, the original two lines are exactly at 90 degrees to each other, right? The deflection angle is exactly 90 degrees. In our drawing, let me go back to the drawing because I dimensioned it. In our drawing, we don't have 90 degrees, we have 96 degrees. Okay, 96 degrees. Back to my sketch. We have 96 degrees. Okay, so the deflection angle is 96 degrees. Here's how I'm going to use the manufacturer's installation guide to my advantage. So let me see if I can draw this. So I'm going to go here, and then I'm going to do this. Right? So here is the 96 degrees. Okay. Now, if you look at each fixture, whoops, there's a delay there. If you look at each fixture, you'll see 90 degrees exactly. You'll see 45 degrees, right? So 90, 45. 22 and a half, and then finally 11 and a quarter, right? 22.5 and 11.25 degrees, right? These are the different things you can buy. Remember, this is 45, this is the 90 here, this is the 22, this is the 11, okay? Those are the changes in direction. If we think about that joint deflection, remember the plus or minus 2 degrees. It means when you install one pipe, and typically the pipe lengths are about 6 meters. When you put the next pipe in, the next 6 meters and the next 6 meters, right? At the joint where the pipe is connected to the next segment, you can wiggle. You can take this and then offline you can go this way or this way 2 degrees. 2 degrees here or 2 degrees here, right? So you can wiggle the pipe. Let me, give me 2 seconds. I'm just going to grab a prop. It'll make more sense. Just hang on. Don't leave. Sorry, I couldn't find what I was looking for. Sorry, I didn't have it ready. Anyway, so you can wiggle the pipe. So if you can, suppose you wanted to go around a curve, you can go 6 meters, then kink the pipe 2 degrees, then kink the pipe 2 degrees, then kink the pipe 2 degrees, right? So 2 degrees, 2 degrees, 2 degrees, and you can achieve what looks like an arc. So if we play around with each connection point, we can have this plus or minus 2 degrees, right? I can wiggle it 2 degrees this way or 2 degrees this way, okay? Now, if that's allowed, actually 3 degrees is allowed, but we're only going to go 2%, 2 degrees according to the region of Halton. Then, suppose in this situation here, I wanted to put in a 90-degree bend, 90-degree bend, right? 190. So if this was a 90-degree bend, right? What am I out by, right? Well, this is 96. Well, then I'm out by 6 degrees, which means I kinked the pipe here and here 3 degrees and 3 degrees. So according to the manufacturer, that'll work, right? 3 degrees here, 3 degrees here, and then the fixture should work, okay? Now, we're not allowed to use 3 degrees, so I'm not going to use 190. I'm going to use 245s. So let's do this. So now I'm going to make them equal, right? So if you want to, you can extend this to here, draw a circle so that this distance and this distance is the radius of the circle, and then connect this point to this point, and now these two angles are equal, okay? So I'm going to do that. And if I put that in, and I use a 45 here and a 45 here, the sum of two 45s is still 90, but I can wiggle here 2 degrees, I can wiggle at this connection 2 degrees, I can wiggle here 2 degrees, and I can wiggle here 2 degrees. Okay, so if I use two 45s, I can achieve approximately 90-degree change, 90 degrees, plus or minus 2, 4, 6, 8 degrees. Which means with two 45-degree bends, I can achieve a deflection angle range from 90 minus 8, which is 82, 90 plus 8, 98. So as long as this deflection angle is between 82 and 98 degrees, and we have that, we have 96, I can get away with two 45s, knowing I can do a little bit of joint deflection here, 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 and here, and navigate that turn. The more bends you add, the more of a range you're going to get. Suppose instead of two 45s, right, because 190 is the same as two 45s, suppose we used four 22.5s, 22.5s, okay? At each fixture, we have a 4-degree wiggle room, right? So here I have 1, 2, 3, 4. If I double that, it'll be 8, right? So 1, 2, 3, 4, 8. Each one is 2 degrees. 8 times 2 is 16. So then with 4 22.5s, we can achieve a 90-degree plus or minus not 8, but double that, 16 degrees. So now I can go from 90 minus 16 to 90 plus 16. And I can make that turn with 4 22.5. The more of these bends you put in, the more flexibility you have with the deflection angle. You have more range, right? So 190 will give you 90 degrees plus or minus 4. Two 45s will give you plus or minus 8. Four 11.25s will give you plus or minus 16, and so on. So the more joints you have, the more flexibility you have. And this is how the installation guide, together with the deflection angle, kind of gives you a way of navigating not exactly 90, not exactly 45, not exactly 11 and a quarter, not 11 and a quarter, 22.5, 22.5, and so on. Okay, so this is the little kind of trick that's played during construction because you understand the manufacturer's installation. Okay, any questions about that? So that's why would it be safe to assume that the more joints you have, the higher the chance of having issues within the pipe? No, the joints, you're allowed to wiggle 3 degrees, and I'm only going to assume it can go 2 degrees, so it's safer. And there's not a problem with that. Now, there are other construction techniques. When you round a bend, sometimes they want you to backfill the trench with concrete around all these fixtures so that they're solid. They don't move. They're called thrust blocks. Okay, but that's a little bit beyond what I'm trying to show you. I'm talking about the installation guide being used as a design guide. I'm not going to give you all the details of construction. That's not really the focus of this course. But generally speaking, when there's a change in direction, they want you to fill the outside of the turn with a block of concrete. Okay? But that, again, that's more of a construction consideration, not a design issue. All right? So when you look at this drawing, and let's go back to this document here. When you look at this entire subdivision, when you look at these corners, you know, you can tell by eye that this pipe, right, that this pipe here, whoops, okay, you can tell that this water main here versus this water main pipe here, they're not at exactly 90 degrees, but they're using two 45-degree bends, which is the sum of 90. But they know they have wiggle room here and here of 4 degrees, 2 on each side. Okay, so it might not look, it looks strange, right? If that's not 90, how do you get away with two 45s? That's how they do it. They use this joint deflection trick. Same thing here. This angle is different, two 45s. And if you look at any of these, you'll see a similar kind of trend. Right? You know this is not 90 degrees to this, but they're getting away with two 1/8 bends or 45-degree bends. Okay, so that's the technique that they use. And notice, again, they're trying to keep the pipe approximately where it should have been, right? Plus or minus if it was curved, right? So if I had to do this, and again, I wouldn't finalize this just yet, but I would put this pipe, right? Remember how I drew this pipe? Oops, remember how I drew this pipe, right? I joined the ends of this curve, right? This point over to this point. That's how I got the two equal angles, right? So from here to here, or from here to here, this is how I drew the angle. And now I'm going to move it. That's too far into the road, and I can move it, over to here. That's too far. The other way, it's going to be somewhere in between, so that the straight line kind of straddles the curve, right? Part of the curve is on one side, part of the curve at either end is on the other side of this alignment. You won't know where to put this until you finalize the position of these two, the end of this pipe. Okay, and we'll talk about service connections next. Any questions about the water main layout? So in all the corners, here and here and here, you can propose two 45-degree bends to navigate what looks like about 90-degree change in direction. Okay, so again, use this as a guide, right? Use this as a guide. See how they did it in this other subdivision, and you can do something similar, right? They've actually done it here. Any of the corners, it's almost always two 45s. And remember, 1/8 bend is a 45-degree bend. What are the text standards for the assignment? The radius annotations in the existing drawings are smaller than those for pipes. Sorry, what are the text standards for the assignment? The radius annotations in the existing drawings are smaller than those for the pipes and water main. I'm not sure what you mean. The radius annotations for existing drawings. Can you give me an example? The height of text. Yeah, so the final drawings that you need to produce at the end of the course are going to be a 1 to 500 scale. So your standard text height is going to be 2 millimeters on paper. So to achieve that, you need a text height of 1 meter, right? So when you're in AutoCAD, the standard text height, dtext or whatever you use, mtext, once you put this in, test sample. So if you look at this, the height of the text needs to be 1 meter high. So if you use the style L80, it'll give you a 1 meter high text. Now, if you want to go a little smaller, but the text height for radius is smaller in the sample drawing. Let me see an example of that. You're talking about here. This text height is equal to this text height. This is a little bit bigger. Don't worry about this. The label for the pipes will take care of itself when we have the style for the sanitary and storm pipe networks. Okay, we'll get into that. Don't worry about that. But these typically are 2 millimeters high, or sometimes 3/4 of that, which would be 1.5 on paper. So you need 0.75. So these are the standard heights. So when you can use a standard height of 1 meter, you'll get a 2 millimeter high text on paper. If it's cluttered and you need to make the text a little smaller, then you can use, I believe there's an L60. Instead of L80, you can go to L60. I don't know if we have it, maybe not. Okay, so then just change the text height. So instead of a height of 1, use 3/4, 0.75. So this is standard text height. This is a little bit smaller, right? And you might want to use this height for your dimension height. Okay, but this is the typical text height. If it's a 1 to 500 scale, which it will be, you want a text height of 1. Okay, and if it gets crowded, you can reduce it by about 3/4. You can use a 0.75 high text. Okay. Yeah, it's good to anticipate that. Otherwise, you do a lot of drafting, and then the text has to be changed, and then you got to move stuff around later. Yeah, that's a good question. Okay, any other questions about the water main layout? Okay, so you need to navigate this corner, and this corner here with a 245-degree bends in all three places. Okay. Now again, a word of warning: everything you see, all this existing stuff, everything in gray, all the existing layers, do not erase, trim, delete, leave everything. Everything you see as existing has to remain on the drawing as existing. Okay. Whatever you add, just put it on, and if it looks like there's something there and there's something new on top of it, leave it. You want to show the new, the proposed stuff. You want to show the old in case there's a removal to consider. Okay, so never draw it as if the construction's done. Don't remove something digitally because it has to be removed in fact, in reality. So leave it in the drawing so it gets identified in the estimate. How do we name the cross and T? How do we name the cross and T? I would use, in the drawing here, they're using the fractions. I would use 90 degrees, 45 degrees, 22.5 degrees, 11.25 degrees. So don't use this notation. Okay, use the notation that I have. Okay. Tron, does that answer your question? I mean in the intersection. How do we name the cross and T? Talking about the water main, this stuff here. Okay, so now you have to decide based on the pipe size. Okay, that's a good question. So there is a valve chamber detail. If you go to the Halton standards, every time the pipe crosses, there's a T or a cross, you need to have a valve chamber. So if you go to the end of this document, you'll find the valve chamber details. Whoops. So there are two valve chambers, 400s. Where is it here? 400, this one. So this is standard 400.01, 400.01, region Halton 400.01. This is a round valve chamber. It's like a manhole for the water main. So this is the round one. And then there's this one. This is a rectangular one. This is standard 400.02. Okay, so you're the designer. You have to decide which structure to use. Okay, and what I can tell you is this. Let's go back to the drawing. Okay, let's go back to the design that's kind of surrounding us. The water main on the main road here, right, the one we're connecting to, we know is a 200 millimeter pipe, right? So we're connecting to a 200 millimeter pipe coming into the subdivision. The loop that we want to create from Chuchmak coming into the site is also a 200 millimeter water main. So we're going to do exactly that. Inside, all the water main proposed is going to be a 200 pipe. Okay, everybody got that? So the proposed water main is all 200. So in this location and in this location, the two inside intersections, which are here, this intersection and this intersection, you're going to have a T, a water main connected to another one, the T location, and a water main, if you trim it here, another T intersection. Okay, notice this is not 90 degrees. Okay, so you need to put a chamber here and a chamber here, a valve chamber. If all the pipe sizes are 200, now you need to decide. Okay, this structure is for any valve between 150 and 250. So you could use this, right? If this is the 200 and this is also a 200, you can use this round chamber, standard 400.01. So this one will work if you choose to use it. This one is for anything between 150 and 300. So again, we've got a 200. So if you have a cross with a 200, right? This shows a cross, but if you had a T with a 200, if you just had a T with the 200, you could use this chamber as well. So you have a choice of the 400.02 or the 400.01. You could use either one, but one selection is preferred over the based on what's in the original design. So if you look in here, I'm not going to tell you where, somewhere in here, there's probably a 200 by 200 T, just like we have, and they proposed one of those chambers. So go find that needle in a haystack. See what they did in a similar situation and use the same chamber. It's either this round one or the rectangular one. Either one will do from a design perspective, but to be consistent, I would see where there's a 200 by 200 T in the site and use the same chamber that they used for that one. Trong, does that help? So you could use either one, but one of them is preferred based on what happened before. So do some research, scan around and see what was done before. There is an example of a 200 by 200 T in this site. That's the big fat hint. Okay, so you got to figure it out. Okay, you really need to study this drawing to get a good idea. Yeah, you want to label the water main, right? So again, you want to put in, if you're going to put in two bends, see these little tick lines, these two short lines? That represents there's a bend there, right? And then there's another one here, a bend here. So those little short ticks. And if you look at the drawing, you can borrow some of the line work, right? That's a T, right? This is a 90-degree bend. So this is the size of the tick, and the distance from here to this intersection is roughly where you want to put the two ticks, right? They're just drawn manually. Right, so that's what a T looks like. You can draw it. That's what a 90-degree bend looks like. You can draw it. If you rotate this, from here this way, negative 45, there's a 45 degree and so on, right? So you can draw these for yourself. You want to label those with the different fixture names. So this would be a 90 degree. Okay, don't use a quarter, it's a 90 degree. So remember, they're labeled according to the manufacturer's guide. So I would use, if you look at the fixtures, 90 degree, and we don't use the word elbow, we use the word bend. So 90 degree bend, 45 degree bend, and then the next page, 22 and a half and 11 and a quarter. Okay, they call them elbows, but we label them on the drawing as a bend, and you can see that here, right? Two 45 degree bends is what's shown. One here and another one here. Okay. Does that help, Trong? Answer your question? Okay. As a drafting guide, look at what was done in the other subdivision and create information that's very similar. All right. So that's the water main. That's just the water main. There are two T's, so you need to propose two valve chambers. So you have to do that. The other thing you need to propose, okay, is two more pieces of hardware related to the water main. You need to lay out the fire hydrants, and you need to lay out the valves, the line valves. Okay, let's talk about the line valves first, and I'll show you a mistake I found on this design. If you go to the region of Halton, and you talk about valves, so let's go here, I'm going to do Control F, valves. Okay, the valves here for the water main. Water valve chamber, pressure valve, here, valves. So here's the line valve stuff, okay? Where is it? Transmission lines, where is it? Okay, the first note, okay? So this is what you want to look at. Okay, let me do this. This is the note you want to look at. On distribution mains, which is what we're laying out, valves shall be provided at every water main junction. So there are valves inside the valve chamber, okay? Don't worry about those valves, okay? Once you put a valve chamber there, it's understood there's valves inside, okay? So don't worry about that. The other thing you want are line valves, okay? So the line valves, which are, I think they're on the next page. Where is it? Oh, sorry, here. Where is it? Oh, here, it's the same note, sorry. It's the same note. So, at every junction, but not greater than 300 meters apart, and place a line valve so that there's no more than 20 units in a residential or commercial institution and 2 hydrants shut off at any one time. What does that mean? Let's look at the drawing. Okay. So everywhere there's a, let's look at this drawing, try and explain that, this one here. Okay, so I'm going to look at this stretch of road right here. Okay, so at every junction we have a valve chamber. Okay, so there's no water main here, that's fine, but there is a valve chamber here. So here's the valve chamber right here. Okay, so there's the existing water main on the main road, and now it's coming into the subdivision. So from there, it comes in, there's no water main on this road, and then to this intersection, here's the next valve chamber. Okay, so there's a valve chamber here, and there's a valve chamber at the existing intersection here. Between here and here, these valves, you can't have more than 300 meters maximum. Okay, so from here to here, they can't be further apart than 300 meters. So if you knew the station values, right? If you know the station value here and you know the station value here, or if you're in AutoCAD, you can measure the distance between these 2 points. I can do it in AutoCAD very quickly. Right, so I'm going from a distance from here approximately to this intersection. It's less than 300 meters. Okay, so you don't need anything in between. If you do get further than 300 meters, then you need to put in another valve. Okay, now the valve you put in is meant to do 2 things. If I put in another valve here, you want to be able to isolate. Like if the pipe breaks, you want to make sure you can shut off the water main so that you don't have water disruption to more than 20 units. Okay, so between here and here, do we have more than 20 units? Well, let's take a look at the drawing. Right, I'm going to look at this. So between this point here and this point here, how many houses do we have? Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So if I shut off the water main between this point and this point, I'll disturb flow to 27 houses. Okay, and that's not allowed technically according to the rules. All right, so what you want to do is put in a line valve, right? A line valve somewhere between here and here so that you can shut off the valves in one of the chambers and then somewhere along the road, and now you can isolate less than 20 units here by shutting this part of the water main off, or less than 20 units here and shutting off that part of the water main valve. You'll notice on this drawing there's no valve chamber. Now there is a line valve here, so you can shut this off, right? There's one here and there's one immediately inside. So you can shut it off here and shut it off here and isolate this little short piece of pipe. So if you shut this off, and again, if you look, there's no other valve. See the V and B, this label here, V and B, valve and box. This is not a maintenance hole. It's just a little cap on the ground that you put a key in and turn the valve on and off, right? So you can't crawl into this space. You can only crawl into these chambers. These are like the maintenance holes. This is not. It's just a little key access. So between here, if you look along the water main, there's no other, up to here, there's no other valve. So here, technically, between this point and this point, there should be a valve to isolate a piece of the pipe, right? Again, I'll draw it. If there was a valve here, we could shut this off, and isolate water just to these units. Or shut this off, and isolate the water just to these units. So in my opinion, this design is lacking a valve box between here and here. Because if you shut this off and you shut this off, you're going to disturb more than 20 units. And according to that rule, no more than 20 units disturbed. Okay, now they made an attempt and they still screwed it up on Chuchmak. So I'll show you that one as well. Here's an example. I'm just analyzing what you're supposed to do and what was actually done. Let's look at this drawing here. This is Chuchmak, just to the north of us, right? Our site's down here. So there's a valve chamber here. So if you shut the valve off in this chamber, if you move along the water main here, you'll see another valve and box here. Okay, again, this is like a maintenance hole. You can crawl inside. This one here you can't. It's just a little cap on the ground. You open up the cap and you put a key, like a long rod, and you turn it. Okay. So if I were to shut this off and shut this off, how many houses would be without water? So let's do the math. And look at the service connections. This is the water pipe that brings water to this unit here, number 5. And notice it's just to the right of the valve chamber. So if I shut this off, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 units on the south side would be without water, and on the north side, I'm going to continue counting, 12, 13, 14, 15, 16, 17, 18, 19, 20, and this one, number 3, 21. So technically, this valve box, if you isolate the water main, if you turn the water off, using this valve and this valve chamber, between these 2 points, you'll disturb water not to 20 but to 21 units. And technically that's not allowed. So what they should have done, and maybe they missed this valve box should be, instead of on this side of the service connection, should be on this side. If you put it here, then there'd only be 20 units on this side. Okay, so to correct the problem, you can move this over to here and have this connection on this side of the valve instead of this side. Okay, so you need to worry about this too. When you lay out your valve chambers in the site, let's go back to the subdivision. How many units do we have on street A? Right? Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 15, 16, 17, 18, 19, 20, 21, more than 20 between this point and this point. Right? So between here and here, there's more than 20 units if you shut off the valves at the 2 intersections. So between this point here and this point here, you need 1 valve box. There's less than 40 units here. So put the valve box somewhere between the 2 intersections, so that if you shut off that valve and either of the 2 intersections, there's only 20 units between the 2 shut-off valves. Okay, so you need at least 1 here, and you'll find between this point all the way around to this point, you've got just less than 40 units again. Double check, you have to count them. If there's 20 units, if there's more than 20, you need 1 valve chamber. If there's more than 40, you need 2 valve chambers. If there's more than 60, you need 3 valve chambers, and so on. Where do you put them? Wherever you like, as long as the shut-off main doesn't disturb more than 20 units. Okay, so that's how you lay out your valve boxes. So the chambers go at the intersection. The valve boxes go on the line of the pipe between the intersections. So you've got a situation between these 2 intersections and a situation between these 2 intersections. Okay? Any questions about that? I wouldn't worry about the line valves until you service each of the units. You need to know where all of the service connections for the water main go. You need to know where all of these are before you decide where to put this so that you can count them. And you can see by my analysis, this would be better off on this side, not this side of this service connection. Okay? And again, you can count the other side. Are there less than 20 units here, right? So if you shut this valve off, if again you shut this valve off, how many units would you disturb, right? Well, you disturb this one, number 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. So between here and the end of the pipe, there should be another line valve. And really there isn't. There should be maybe another one right here near the intersection. So they kind of cut a little bit of a corner here. I would probably have at least 1 more line valve. Again, when you shut off a piece of the main, you want to disturb no more than 20 units. Now in this dead end, it's kind of trivial because there's no loop through here, but it would cause a problem, right? So Chuchmak is a little bit substandard in my analysis of and my interpretation of the standard. Okay. The other thing you need to lay out is the hydrants, right? The hydrants look like this. Right? If you look on the road, on the water main side, you see that hydrants, right? HYD and valve, so that's the label. There's actually a valve here. There's actually a valve here that we don't draw. It's understood that there's a valve to shut water off from the main to the actual device. If you look at the region of Halton standards, there's actually a drawing for it. It's at the end of the document. You'll see the hydrant. Sorry to do that very quickly. So the hydrant and valve looks like this. Now, this is basically what the hydrant and valve looks like. This is on an urban, a rural road. There is an urban version of it. I don't know why they don't show it. That's temporary. They don't show the urban version of it. Oh, here it is. So this is maybe the urban. So you've got the water main, right? The main line of the pipe, and then it branches off to the hydrant. But between the main and the hydrant, there's a valve. But in the plan view, we don't draw the valve. We just label it hydrant and valve. It's understood there's a valve between the main and the actual hydrant. So if we go back to the drawing, if we zoom in on one of the hydrants, right, here's the hydrant, right? On this pipe, there's actually a valve. There's a valve here, but we don't draw it so that you can shut water off from the main to the actual hydrant device. Okay, but we don't draw it, we just label it hydrant, HYD, and V. And that's what the drawing looks like, right? HYD and V. So we don't draw it, we just label it. Where do you put the hydrants? The hydrants now are based on a maximum distance. So if we go back to the standards here, hydrant layout, so I'm going to just search the document. So hydrant, and here we go, dead end, maximum allowable, where is it? Maximum distance for the hydrant is, here we go. So here's the table. So if you look at table A47, it tells you in a residential neighborhood, which is what we have, maximum spacing 150 meters. So from one hydrant to the next hydrant, 150 meter maximum distance. Okay? Now, that's the standard. The way we put that into practice is a little bit different. Okay? What we're going to look at is this. Go back to the drawing. Okay? What we look at is, if I know that this hydrant is here, I'm going to draw a circle with a center line, with a radius at the center of the actual hydrant, and I'm going to draw a circle with a radius of 75 meters. Okay? So there's 75 meters from here to here. Okay, now I'm going to find the other hydrant. Here's another hydrant. I'm going to draw a circle from the center, also 75 meters. If these two circles touch, I know the distance between the two hydrants is 150 meters, 75 plus 75. Two of the radii equals 150 meters. So here we go. So you'll see this versus this. See how they're not touching? It looks like there's a hydrant missing between here and here. Okay, now you might not have everything you need on the CAD file. Let's go look at the actual PDF. I think there's another hydrant here somewhere that might have got missed on the CAD file. So let's take a quick look. So on Chuchmak, right, this is the first hydrant where I drew the circle. This is the last hydrant here where I drew the last circle. And somewhere between, well, yeah, see, there is a hydrant right here between unit 2 and 3 on the north side. So if I drew that circle, then the 3 would overlap. So this hydrant is actually missing on the CAD file that I gave you. Okay, if that were there along the line of unit 2 and 3, let me see if I can draw that. See that the unit lines are missing. I can't even draw it. Let me see if there's a dimension. Is there a dimension? Not really. So it's unit 2 and 3. So I'm going to assume the unit width here is the same on both sides of the road, is the same as what we're doing on our site. So I'm going to go from this block line, I'm going to go 1, 2, 3 units over, starting on the edge. Right? I want this distance. I'm going to go to my CAD file, and I'm going to start here, and I'm going to make a copy. Let me see if it works. A copy of this stuff from here over to here, and I'm going to ignore the last few. Okay, but from here I'm going to go 1, 2, 3 units. Let me see what that is. From here I'm going to go 1, 2, 3 units. 1, 2. So there should be a hydrant right here. So I'm going to make a copy of this hydrant. Should be approximately. This is what's missing. Now you don't have to do this. I just want to show you for an example, right? So where does the hydrant go? I'm going to offset from the center of here, perpendicular to center. So that's the offset to the center of the hydrant. I'm going to make a copy of that from the center, intersection of this offset line and this unit line. That's where the hydrant should go. Okay, so there should have been a hydrant there, and it's not showing for some reason. Okay, if I draw a circle here, 75 meters, you can see this circle intersects this circle. If they were just touching, right? If I take one of these circles and I move it over, if they were just touching, I'd have 75 meters from here to here and 75 meters from here to the center. But you can see they're clearly overlapping. So when you're overlapping your circles, you know that the center of the two circles are less than 150 meters apart. Okay, so that's how we kind of lay out the hydrants using these circles. Now we don't just look at the distance along the center line of the road, we actually look at the lot coverage. Okay, this is kind of weird. Okay, so you don't have that hydrant there. Don't worry about it. We're not checking what's happening outside the site. We want to make sure that we get our site. So I want to know where this one is, and I want to know where this one is. What's happening in between here is not that important to what we're going to do. But let's draw some more circles here. I'm going to draw a circle from the center of this hydrant, 75 meters. I'm going to go to the next hydrant. Next hydrant is here. I'm going to draw a circle, center, 75 meters. Notice these two overlap, which means the distance between the center of this circle and the center of this circle is less than 150 meters. Everybody see that? And if I keep going, I believe there's another hydrant north of here. So from here, if I go north, I think there's one at the intersection. Again, it's not a complete document. So I found this hydrant, and I think there's one at the intersection or near the intersection here. The water main jogs across the street, and there should be a hydrant nearby, I hope. Hydrant here, and then there's a hydrant here. So you can see there's one here and one over here. Those two are pretty sure less than 150 meters apart, and so on. So we use this circle technique, and what we actually look for is the coverage. We want to make sure that the houses that are on the road where the hydrant is completely inside the circles, so that you can drag a hose all the way into each backyard. Okay, so what am I talking about? Suppose I move this hydrant. Suppose I move this hydrant here by moving the circle. If I move this north, if I put a hydrant here, right, if I ended up putting a hydrant here, the distance from this center to this center between here and here is 150 meters. But then you'll notice there's this sliver between the backyards, right? There's this sliver here that doesn't have coverage. And they look for that. I've seen it. When you hand in your drawings, the reviewer of the design will draw all these circles and look for these backyards that aren't covered. So then you would have to move that hydrant over so that everything is inside the overlap of all the circles. If there's any gaps like this, they're going to make a comment. Yes, they're less than 150 meters apart along the road, but there's a part of the backyard that's missing. So you want all these circles to overlap a little bit, and you want to make sure that there's area in the backyard inside one or the other or both circles, right? So you don't want, and I'll show you here, right here, there, this little piece here is missing, so that's no good. So what am I talking about? We need to place hydrants inside the site. Where do you place the hydrant? How do you know where to put the hydrant? What's the distance from the center of the hydrant to the right of way? That's on the standard. So we can look at E2 again, right? So if we go back to E2, this one here. So if we look at E2, how do we draw the hydrant? Well, we know the hydrant is 2.6 meters away from the street line. And the hydrant is on the same side of the road as the water main. We wouldn't put the hydrant on this side. We don't want to cross. We don't want this part of the pipe to cross the sewers. So wherever the water main is, that's the side of center that the hydrant is also on. And you'll see that in the drawing already, right? Here's the center line. The water main's on this side, so the hydrant's on that side. We never cross the sanitary and storeroom sewers. We keep the hydrant and the water main all on one side so that we don't have any crossing issues. So the offset is 2.6. So to draw that in our subdivision, if I wanted to put a hydrant, say over here somewhere, I would offset 2.6 from the street line. So anywhere on this line is where I can put my hydrant. Same thing here, offset 2.6. Anywhere here I can put my hydrant. Okay. Where do you put it? Well, you need to know where all your driveways are. You can't put a hydrant in the middle of a driveway. So this is something you do after your driveways. You don't put a hydrant in on top of one of your water or sanitary sewer connections. So you have to service each unit. What do I mean? Before you lay out your hydrants, you want to know for each lot where is the sanitary connection and where is the water main connection. So you want to lay out your services first. You want to lay out all your driveways first, so that then the hydrant is not in a driveway, is not on this pipe, is not on your sanitary pipe, right? Because you can't have the hydrant on top of anything else. So the hydrant is one of the last things you do. You have to lay out your driveways first. You have to lay out your water services first. You have to lay out your sanitary services first. There are no storm services. Okay, they're using sump pumps. I'll show you that detail in a moment. You want each individual lot, driveway, sand, and water connection determined first. And then you worry about your water main hardware. Where do you put the hydrants? Where do you put the valves on the line? Okay, so it's one of the last things you do. So let me give you an example. Any questions about the hydrants and the water main? I predict, I haven't done the exercise this year, you're going to need at least 4 hydrants. Okay, that's my guess. I haven't done the design myself, so we're kind of doing this together. I'll have to do it to mark it so that I know it's good. But if you look at our subdivision, I'm predicting, I'm going to draw a circle, 75 meter radius, 75 meter radius, 75 meter radius, 75 meter radius. I predict you're going to need at least 4 hydrants, right? Somewhere over here, right? And that's not close enough. You want them to overlap so that there's no backyards unaccounted for. So I'm just roughly figuring out. And then I want the center of these. That's roughly where the hydrants are going to be. And you can move them both together now, right? Where are we going to put these? Okay, these as well. They're not close enough together, right? You want them to overlap, right? That's no good. There's part of the backyard not covered. Move them close together. And then you can move them both back and forth. And make sure you have coverage. I think you can do it with 4 hydrants, worst case 5, but try and minimize the cost. Hydrant and valve costs about $3,000 to $4,000. So if you can do it with 4 instead of 5, you're going to save that much cost to the project. But I think you're going to have about 4 hydrants, 2 on street A and 2 on street B. That's my prediction. Where exactly they're going to be is going to depend on your servicing. Where's your driveway? Where's your sanitary connection? Where's your water connection? And again, there's no storms. What they're doing for storm is a sump pump. And I think they have a detail for that in here, I believe. Oops, Control F, sump. Oh no, it's in the drawings, sorry. It might be in here. Next set, sorry, 19 to 32. Sump pump looks like this. Whoops, like this. I believe they're doing this as opposed to this. There's 2 options. So basically the storm sewer is not as deep as your footing. So to collect the water around your footing, there's actually like a pit inside the house, and then they pump it up over the foundation wall. They might pump it into a pipe that goes into the sewer, and I don't think they're doing that. They actually, otherwise we would have to draw this pipe, or at least this piece of the pipe in the right of way. So they're not doing this, they're actually doing this. So again, they're pumping the water that accumulates around your footing into a pit in your basement, and then an electric pump will take that water up over the foundation wall onto the ground. This will go along your front lawn, into the roadway, into the street sewer, into the catch basin, into the street sewer. So this is what's happening. So there's no storm connections. And if you look at the drawing from the previous subdivision, you'll see that there are no storm connections, just sanitary. Right? This is the sanitary pipe. This is a pipe. It's a dual. It connects to both. Okay, so sanitary and water only. So let's look at some service connections and details. Okay, any questions about what I've said so far? So you got to lay out the water main with the bends. You have to lay out the hydrants, the valve chambers, and the valve boxes. That's part of this submission. But don't do any, you can lay out the water main, the pipe, but don't lay out the valve boxes and hydrants until you've serviced all the lots. Okay, there's a lot of that to do, but it's very, very repetitive. You have examples of what those dimensions are. Now, there are standards which they didn't follow. So let's look at the standard, and then we'll look at the actual Okay, so here is a single family residential lot. So 1 unit, 1 unit, 1 unit. This is how you service. Okay, so let's look at the middle one right here. Right? If we have a property, how do we get water, sanitary, and storm to that property? Right? Well, there's two ways of doing it. You can do a dual connection. Right? So there's one pipe, and then it splits off so that one part of the pipe connects to this house and one part of the pipe connects to this house. So this is called a dual connection, a shared service. Okay, that's one way of doing it. So every other lot line will have a double. Okay, and if you look at the design, you'll see that here. Right, this one pipe services both of these lots. Right, you can see the branch off here. Right, then you skip this corner and you go to the next one. This one pipe services these two lots, and so on. So these are called duals, dual connection. Okay. Now notice there's no storm sewer, so it's just a sanitary. Okay. So as much as this is the this is the standard, right? We only show the sanitary pipe, and it's right on the center. Okay. Notice the split happens outside the right-of-way in the road, but on the drawing they show those inside. Okay. So the drafting is a little bit different, but that's fine. It's just a symbol, really. The other thing you'll notice is the water main. So if you take the center of the lot, right, 1.5 meters to one side, and if you stand on the road and face the house, is this the right or the left side? Is this offset right or left? Is this 1.5 meters right offset or left offset? If you're facing the house, are you putting the service to the right or to the left? The right. The right. So when you face the lot, if you stand on the road and look at the house, this is on your right side. Okay, so this is a dual shared connection, but we're only going to put in the storm, and it's right on the center. This is a single water main. There are no double water mains. Okay, they're always separate. Okay, so this is a shared connection. Now, if you have an odd number of houses, one of the houses needs a single connection. So you'll see that here, right here. All right, so from the center line, you always put the water on the right side, 1.5 meters away from center. And the sanitary and storm, you put them on the left side, 1 meter away, and then a certain distance between the two pipes. Okay, and there's a drawing for how close those pipes be together. We don't need to worry about it because we don't have a storm sewer. Okay, so from the center of the unit, you go 1.5 meters to the right and 1 meter to the left for water and sanitary if it was a single connection, one pipe, one house. If you're going to share them, which is more cost effective, you put them between the units. But the water is always 1.5 meters to the right, 1.5 meters to the right. Okay. Here they're showing it 1.5 meters to the left. You see here, they're showing it 1.5 meters to the left. And why did they do that? Because it depends on where you put the driveway. Okay, so this is the standard. Let's look at what they actually did in practice. So if Professor Neruzzi asks you what's the standard, you can quote E15A. However, the other engineer did something a little more practical. Okay, so let's look at how they laid out single lots for water and sanitary, and there's no storm. Okay, so let's look at the actual drawing. So this is the standard. This is not exactly what was done. If we look at the general model, and we can look at any single units, right, single individual homes, you'll see they paired them. So the sanitary, two together. The sanitary, two together. The sanitary, two together. The sanitary, two together. So they paired them. If there's an odd number, then they went with a single. Where did they put the single? Well, they put the single. Where's an example of a single? Right here, this unit. See this single line? That's the sanitary connection. One pipe, one house. Whereas this is one pipe servicing two houses. Okay? So this doesn't need a dimension. It's right on the corner of the property between the two units. This one here should be dimensioned. Where is this pipe? How do you know where to put it? So there must be a typical dimension somewhere. And I believe, if I can find it, right here, 6 meters. Oh, no, not 6 meters. It's, where is it? There's a typical dimension. I found it. I think it's on this street here. Here it is, 4 meters. So it's 4 meters from the corner closest to the driveway side. And here's another, that's not typical. That's actually, it doesn't say typical where the water service goes. They move that from typical because of this valve chamber. So let's talk about this. I'm going to draw it. I think it's easier if I draw it. Okay, we're talking about single units. Let's go to the, let's go to my handwritten drawing. So let's suppose we have a bunch of houses. All right, so these are all single lots, not townhouses. Okay, if my back of curb is here, okay, my center line of road is here. If the profile is falling this way, we want to lay out the drive first on the high side. So between these 2 points, this is the high side. So we go 0.6, remember this offset, 0.6, 0.6 offset. And then we go 6 meters for the driveway, right? And where it's offset from the lot line. You want this and the driveway to be parallel. So there's my driveway. Okay, and I can draw those all here. From the high side, 0.6, 6 meters away. From the high side, 0.6, 6 meters away, and so on. So these are my driveways. How do we do the sanitary connection? Well, 1, 2, 3, 4, 5, 6. There's 6 units here. Let me draw one more just so you can see the odd one. Suppose there were 7 altogether. I would pair them. This is how I would do the sanitary. I would draw a pipe right from the corner to the sanitary sewer. Right? Let's assume this, the sanitary sewer is right in the middle, right? Center line of the road. So I would draw one pipe and I would branch off into the 2 lots. Then I'd skip this because this is already serviced. So I'd draw one pipe, branch off into 2 lots. And here I would draw one pipe, branch off into 2 lots. This one here, and let me draw the driveway, right? Remember it's falling this way, so this is the high side. So here's the driveway, right? 6 meters wide, 0.6 offset. Where would I put the service connection? From the high side, I'm going to measure 4 meters. So from here, I'm going to offset 4 meters, and I'm going to draw a pipe to the center line so that the distance from here to here is 4 meters typical. Oops, typical. So the driveway is sited from the high side. The single connection for sanitary is dimensioned off the high side as well. So the service connection is actually under the driveway, which is fine. Okay, so pair them, and then when you have to go single, it's 4 meters from the high side, just like the driveway is sited from the high side. Okay, so do your best to pair them, and then when you have an odd lot, you have to put in a single. Now you might do that now, and then when you come back and you have to put a hydrant in, well, you don't want to put a hydrant in over the pipe. So then what you might want to do is, instead of having a single here, a double here, you might have 2 singles. So you then, when you're laying out your hydrant, you might have to put a single here and a single here to make room for the hydrant and get rid of this double. That could happen, but you won't know until you start laying out your hydrants. And you won't know that you have to do that until you lay out your service connections first. Okay? Or if you know you want to put a hydrant here, maybe you put the double here, maybe you put the double here and the single here. So you switch. Right? Put the single connection here, put the double here, and then your hydrant goes here. But you won't know that that's kind of what you need to do until you know where all your service connections are, and then you try and locate all your hydrants. Okay? So it's a little bit of a game. This process, and you have to embrace it because it's not something that you have control over. You have to do some of the work. And then once you do some work, you add more work. And once you add more work, it may prompt you to revisit what you did first. And over time, you're going to kind of iterate, right? So let's say you'll lay out all the service connections. You're happy with that. Then you go to lay out the hydrants. Oh, that's not going to work. And you have to make an adjustment. Oh, now I'm going to lay out this other thing. Well, that's not going to work. And I have to make an adjustment. So you have to start. And then as you add the different layers of data, you'll see that you may have to revisit something you've already done. And don't get angry, don't get upset. That's just the nature of the work. Okay? You do the work, and as you add more detail to it, you'll find you may have to revisit something you've already done. Okay? And I've said this before. This is an iterative process. You go through a cycle, and you go through a cycle, and you go through a cycle, and then you may have to revisit work you've done before. Okay? It's an iterative process. Ideally, you want to iterate once, which is impossible. Okay? It's just the nature of the work. Now you will, over time and experience, the more experience you have, you will iterate less. obviously, because you'll have some tips and tricks and understanding of how this stuff works. But certainly at the beginning, you're going to do the work, and as you add more information, you're going to might have to change some of the work you did before. And that's going to be true all the way through this design, okay? Because later, much later in the course, we might have to put in rear lot catch basins. So suppose I need a catch basin here. Well, now I need a pipe down here. Well, now I can't put a double here, so I'm going to put in 2 single sanitaries to split it so that I don't have 2 pipes on top of each other. I won't know that that's a problem until I go to lay out all my catch basins in the backyard. Where do my catch basins in the backyard go? Depends on my lot grading. That's one of the last things we're going to do. So you're going to revisit your servicing layout once, twice, maybe 3 times as you advance the design. Okay? And again, don't get upset. It's just the nature of the beast. I will mark what you've done at each submission as acceptable, as good, and then later, if an adjustment is required, I expect you to make those changes. But we won't know what they are until we advance the design all the way to the end. One full cycle. Okay, so this is just some advice on what the design process is and how it's going to work. Okay, so that's the sanitary service connections. Okay, so just lay them out. You may have to change them later. That's just the nature of it. The water service, okay, that's sanitary. Sorry, then there's sanitary for townhouses. So let's look at that. Sanitary for townhouses look like this. So these are the single lots. So they're going to be doubles, or they're going to be typically 4 meters on the high side under the driveway. That's how you do your service connections for sanitary on single residential lots. If you've got townhouses, it's similar. Let's look at those here. You're going to pair them just like that, right? 2 together, 2 together. Never put a dual between blocks, right? Never put a dual between blocks, right? Leave this spot between the 2 buildings free because you might have a rear lot catch basin back there. Okay, and we'll look at that later. So never put a double here. Always put in your doubles interior. If it's an even number of units, it's easy, right? You pair these 2, you pair these 2, you pair these 2. No dimension required. Everything works out. Okay, so those are doubles. If you have an odd number, and there is one here, if you have an odd number, you pair as many as you can. So there's a pair, there's a pair, there's a pair. And then under the driveway, you put in a single connection. Instead of 4 meters, we use 2.5 meters. So it's very similar to single homes, townhouses. If you have double connections, they're easy. You just put them between the units. If you have a single, it's under the driveway by 2.5 meters. If it's a residential single lot, it's 4 meters. So the dimension's different, but the technique is the same. Single units, typical 4 meters. Let's look here again. Single units, 4 meters for the sanitary connection. For a townhouse, single connection, same technique, different dimension, 2.5 meters. If you have any of those, label at least one, typical, right? So then if I see another one, is there one here? See here, 1, 2, 3, 4, 5. One of these is odd. Okay, so they labeled it again here. See, 2.5 typical for this service connection, for the connection to the pipe. They could have left this dimension out because they labeled this one typical 2.5. So I know if there's no dimension here, I know it's 2.5. Okay, but you need at least one. Okay, so that's how you lay out your sanitary services. Water services, I don't know if it's in the standards. You might have to look it up. They don't want the valve box, right? Right here, there's a valve. You can turn a key here to shut water off to the unit, right? The municipality can shut your water off if you don't pay your bill. These round circles here are the water boxes, or they're called the curb stops, okay? Those, they generally, most municipalities, sometimes it's written into the standard, sometimes it's not. I can't remember in Milton what the standard is. But they don't want those in the driveway. They don't want the cars driving over these things because they get damaged over time. So they're always outside the driveway. So if you look at the single residential houses, there's always 2 categories. Where do the water services go? And there should be a typical dimension here somewhere. Here it is. Okay. So if the distance from here to here is 0.6 to get the driveway, and the driveway itself is 6 meters, then the distance from the high side corner, edge of the driveway on this side, is going to be 6.6. From the same corner, we lay out the water service, and it's 8 meters away. So if this is 6.6, I know the distance here is 1.4. 8 minus 6.6, 1.4. So that guarantees that these services are always outside the driveway. So this is the typical dimension. So every time you draw one of those, right, if there's no dimension, if you label one 8 meters, right, if you label one 8 meters, the next time you see one, you know that this is 8 meters away from this corner. And you know that this is 8 meters away from this corner, and so on, because there's one typical dimension. So once you have a typical, when you see something without a dimension, you know that the typical dimension applies. Okay? If you deviate, like here, see here, 6.9, it's very close to the edge of the driveway. It's about a foot away, right? 6.6 minus 6.9 is 0.3. So that's there. This is not typical, so it has its own dimension. Why aren't they using 8 meters here? Because they had to move it away so that the water main doesn't go underneath this transformer. This is a transformer for the electrical design. Now, we won't have these. We won't know where these are. Because generally, when we do our work, sanitary, storm, and water, we provide that to the other utilities, and then they lay their stuff out after. And if there's a conflict, there's a coordination that has to happen. So we won't get that far advanced. Right here, there's a light standard. Notice they curved the pipe, the water service around the light pole. Well, you won't know to do that until you know where the electrical engineer laid that out. And you won't know that this has to be 6.9 instead of 8 until you know that there's a transformer there. Okay, but we're not going to have the electrical information. So again, we're in the first kind of iteration of the process. We're going to do our layouts for sandstorm and water. And then theoretically, it would go to the electrical engineer. They would lay out their stuff, and then we'll check to see if there's conflicts. So you're always revisiting the design based on getting closer to the final completed design. We won't be dealing with electrical, but that you can see there's some adjustments required ultimately, or there may be some ultimately required. So that's how you lay out the water service for single lots, 8 meters from the high side, and that's all you need to do. If it's a townhouse, they do this. 4 meters either side of wherever the driveway common point is. So we know the driveways are 3.5 wide. So if we go 4 meters, we know we're going to be ½ meter away from the edge of the driveway. So that's typical. Now notice they labeled it all the time, right? Typical 4, typical 4, typical. You only need to label the typical once, and then we know that applies, right? So there's no label here. I know this is 4 meters, 4 meters, and 4 meters. I know this is 4 meters and 4 meters. Okay, if it's a single, if you have a single, for whatever reason, it has the same dimension. This, I know, is 4 meters away from this point here. This distance is 4 meters. Okay, so you need to label at least one. And that's how you lay out your sanitary, your water service connection for each unit. Each unit has a service connection for sanitary. They're individual. They don't double them. They don't share a common water service. They can share a common sanitary service, but not a water service. So again, look to this as a guide. How do you service the singles? How do you service the townhouses? Because we have a bit of both, right? Mostly singles, but on the north side of Street A, we have a bunch of townhouses. Okay, so I'm gonna lay one out. So here's my driveway on the high side for this lot. Right, I could lay out my sanitary service here. So I'm going to draw a line. Here's one example. It doesn't have to be here. Perpendicular to the center line of the pipe. Okay, and then I draw a line. I'm going to draw a line here. I'm going to make a copy of this. Bring it here. Rotate it 45 degrees. Put it here. Mirror that on the center line of the pipe. And then I'm going to offset it. I'm going to use about 1 meter. Again, it's schematic, about 1 meter into the lot for the length of this. So there's your sanitary service connection. Okay, and it should be on its own layer, different than the mainline pipe. Right, so this is the main line. Don't worry about that just yet, but I would put this on a separate layer so you can count them separately. Then I can make a copy. And I can skip every other unit. I don't need one here because it's already serviced. So I go put one here, skip this one, 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 and so on. So I can double them, right? Does that make sense, or do I need to shift them all by one? Well, you need to take a look at that, right? If I put one here, not here, but here, and then here I don't need a dual. Now 21 is got 2 services. So now I can make 22 a single. Or I can shift all the other ones. I can take all of these all the way down the line and shift them by one. So now I've got a pair here, a pair here, a pair here. So you have to decide how you want to kind of lay it out. Okay. When you get into the corners, perpendicular to that short pipe, right, you might have one there, or two singles, or whatever you need to do to make this work. Okay, and that's why this short pipe is required, so you can have the service connection perpendicular to it, or as close to perpendicular as possible. It's not always exactly 90 degrees, but you want it to be as close as possible, and you'll see examples of deviation of that here. Once you get into these corners, right, how did they do these? You'll see here. See what they did here? See, they kind of kinked the pipe. So this is exactly 90 degrees. Do your best to make it as close to 90 degrees as possible. If you're not going to make it 90 degrees, make sure it's at least pointing downstream. So the connection to this pipe would be pushing the wrong way. Okay, what do I mean by that? I'll show you here. You don't want to buck grade, they call it. Right? So if your sanitary pipe is doing this, and it's flowing this way, and it's flowing this way, and you have a service connection coming from this side, right? If I have a lot corner here and I want a service connection, whoops, over here, right? I can't go perpendicular here, I'll miss the pipe. I can't go perpendicular to this one, I'll miss the pipe, right? So it's a problem. What am I going to do? Well, I have a choice. I can put it here close to 90 degrees, or I can put it here close to 90 degrees. This one I wouldn't do. And the reason for it is because I'm taking the flow and pushing it against flow coming in. And now this could come up the pipe, which is no good. So if you're going to hit the pipe, if the pipe is flowing this way, if you're going to hit the pipe at 90 degrees, good. If you can't do 90 degrees, always go downstream, not upstream. This is not allowed. It's not preferred, right? So ideally, exactly 90. But if you have to shift it one way or another, always point down the pipe, right, in the direction of flow. So now the flow is nice and easy. If you do this, this flow could jump into your pipe and cause you problems. So hydraulically, it's not preferred. And that's why you see that solution on the subdivision that I just showed you. Right? So it's better to connect to this downstream pipe in the direction of flow than to kind of push it up against the flow coming at you. So this, you don't want this flow going into this pipe, right? This flow into this pipe, you want this flow kind of naturally flowing into this one. Do your best. I think there's a way of improving this. You probably could have made this a little better. Like maybe you can push this manhole further back and have 90 degrees to this pipe here. But again, it's acceptable, but do your best to keep it at 90 degrees if possible. Okay, that's your sanitary. Then your water main, again, offset 8 meters. Extend to the water main, trim it. Put this service connection on a different layer, right? Not the same layer as the pipe, but on a different layer, and draw the circle, the little service connection. You could borrow from here. You want to draw this and this. You can use the layer names existing and just change them to proposed, the C proposed. So you could put this. Okay. Now here's the trick, and this is important later when we do our cost estimate and when we do our others. This pipe is underground. This pipe is underground. This curb stop is like a manhole or a maintenance hole. It's a surface feature. So think about your grading plan. Anything underground should not show. So on the grading plan, we're going to turn off this layer and this layer. We're going to turn this off. We're going to turn this off. But on the grading plan, we want to see this. So it should be on a separate layer. Okay? And for counting purposes, this is the main sewer. There's a certain cost associated with that. This is the service connection. There's a cost associated with that. So these should be on 2 different layers. And then this should be on a 3rd layer. So water main, water service, underground, curb stop. 3 different layers. And you're setting yourself up for the drafting presentation later. If you look at the drawing, let's see if I can find it here, the grading plan. Here's the grading plan for the entire subdivision. Oops, not this one, sorry. The grading plan for the entire site is general. I don't know if it's on here. Grading, grad model, this one here. So here's the subdivision grading plan. If you zoom in on it, you'll see there's no underground pipes, but you do see the water service, right? So the sewers are all on layers that are going to be frozen. The service connection is also frozen, but the curb stop, that circle, is above ground. You would see it, so you'd want to make sure it's on a different layer. Okay? I don't know if you've got a copy of this just yet. I'm just giving you a heads up. Anticipate what you're going to do later for the drafting. And again, change the layer not to existing but proposed. So you can call it C water service instead of existing water service. So you can borrow some of these layers, the names, right? This is called existing water pipe. You can call it C existing water, or water, sorry, C water pipe. You can call this C water service, and so on, right? But you'll see here, watch, this, oh, they put them on the same layer. I wouldn't do that. I would make these separate. So you can turn off the underground stuff, but have the above ground separate. The service connection for sanitary, it's all one layer, because it all disappears as well. Okay, so you can follow the layering scheme of the original site. Okay, so that's the servicing and so on. So there's a lot of work to do. I will give time next week to kind of ask some questions. This is one of those courses I described this for. I wish I could teach this course to you after you take this course. And then we can talk about actual design issues as opposed to how do you do stuff. Okay, and how do you do stuff is skills you've already got but never used before to do this kind of work. And so far, everything we've done is all AutoCAD. We haven't done any Civil 3D yet. We're going to get to that bit today because it's the last requirement for the assignment. So if we go back to the requirements, submission 1 requirements. Right, so we did the topo, and we have the surface and the base plan. We did the base plan. We talked about the center line. We talked about the edge of pavement, back curb, sidewalks. That was with the driveways and the sanitary storm and the water main layout. That was the first week's work. Today we talked about hydrants and valve chambers. Hydrants and valve chambers. We talked about it, but remember, you have to do your services first. Do these first before you do this. Hydrants and valves. Okay, so sanitary connections and water service connections, do them first. This first, and highlight it, do this first, and then come back and do the hydrants and valve layout. Okay, so this is a little bit backwards. This should happen after these two. Okay, and then you need to define the center line of the road and draw the profiles. Okay, just define the center lines and the profiles. I'll do one, you have to do two, both roads. Okay, let me do this and then there'll be some time for some questions because we still have about an hour left. Okay, any questions about those so far? The service connections, the hydrants, the valves. Okay, so please make note of that. This list should have been a little bit better laid out. You have to do your sanitary and your water connections before you do the hydrant and valve chamber layout. Well, the hydrant and yeah, I would do this second. Okay, so switch these. These two bullets should happen before this one, right? Yellow before blue. So make a note of that somewhere. Otherwise, it's not going to make sense. Okay, so there is a little bit of an order to what needs to happen. Did anybody go ahead and start laying out their services? Remember, you can unmute yourself. I'm allowing audio if you want to talk. If you want to ask a question. Okay, if you're not talking, stay muted, please. But you can unmute yourself if you want. Sorry. Yeah, so let's create the alignments. I'll start with Street A. I'll do both, but it's more of a review. I'm going to isolate the center line proposed, the existing center line, the street line proposed and existing. Okay, so we're just going to look at these, right? Center lines and right-of-ways. Okay, these hydrant offsets you don't need to worry about. So to define the element, okay, here's how you do it. This is review. You go to alignments. You go to alignments, and you want to create by polyline. Okay, so before you use this command, make sure you have one continuous polyline, right? So I'm going to list this. This is the easiest one. It's just one line. So it's a line. I'm going to create a polyline edit. Say yes, and now it's a polyline. So if you list it, it'll say polyline. This alignment for street B, you want it to start at the beginning, the original beginning, and create the alignment all the way through and then into the site. So this is the polyline for the entire street. Part of it is existing, but we still need to define it, and the rest is proposed. Okay, I'm going to turn off the existing center line for a second. So you want to leave this layer, the center line existing. I'm going to turn it off, but you still want to have the geometry proposed for the whole thing. Okay, so just be mindful of that. Okay, so this is the alignment. Don't start here, right? Make sure you start at the beginning, the original beginning. Here's how you create an alignment. So alignment, create by polyline. Again, this has a midpoint. Depending on which side of the midpoint I select will determine where chainage begins. Okay, so I want these 0 at this end, and I want positive chainage to increase into the site. Okay, I don't want 0 here, I want 0 here. So I need to click on this half of the line. So when I click here, I've selected everything I want. I'm going to hit enter. You're going to see a little arrow cueing you the direction of chainage. See that arrow? So it says chainages are going to increase in that direction. If you're happy with that, hit enter. If you're not, you can type R for reverse. Okay? So let me show you the other side. If I pick it here and I hit enter, see the arrows backwards? So if you pick it on the wrong side, I can type R, enter. If you pick it on the correct side, you can just hit enter, and then chainage will increase in that direction. So you can always redeem yourself, right? But I would make a mental effort to pick the end of the polyline that is closer to the beginning, and then you don't have to worry about reversing it. So alignment, create from polyline. I'm going to choose close to this end, enter. Yep, that's correct. I'm going to hit enter. You'll get a dialog box, right? So you'll name it Street A. And then you can accept the defaults, except this, turn this off. Don't add any curves. And you can delete the original one. Okay, now turn on all your layers and you should see that alignment. If you don't see it, regen, and you should see the alignment. So there it is. There's the alignment. Notice 0 is at the beginning and positive chainage is increasing into the site. 80, 100, 120, and so on. The next thing you want to do is move where 0 is. You want 0 to be where the two center lines cross, the intersection of this and the line. That's where 0 should be. So again, you do not move the label. That doesn't do anything. Right? If I snap to here, that doesn't do anything. That just moved the label. 0 is still here. So leave the labels alone. To change the location of where 0 is defined, you click on the alignment, you right click, you go to alignment properties, and then you go over to the station control tab and you click on this button here, and you're going to select a new location for where 0 is going to be. So you click here, it's going to warn you, do you want to do this? Say OK. And now you're going to use your OSNAP INT intersection and snap where the two center lines cross. And when you say OK, watch what happens to the label called 0. I'm going to say OK. And now label adjusts to the new position. Okay, I'll do it again with the other road. I'm going to turn off. So here's the alignment, right? There's the center line for Street B. So let's do it again. Alignment, create from polyline. Okay, and it's hard to choose here because there's the existing and the proposed. So I'm going to pick this corner here, which is still closer to this end than it is to this end. So I'm going to choose this kind of corner here. I'm going to hit enter. Here's the little Q right here in the corner. See the arrow? Yep, that's the direction of increasing chainage. Correct. I'm going to hit enter. And then change the name, Street B, turn this off, say OK, and you get your alignment, and it's increasing in that direction, 80, 100, 120, 140, and then we go to the intersection, and we tell it, hey, 0 shouldn't be there. It should be right where the center lines cross, right there. Okay, so we right-click on the alignment, alignment properties, change the position of where 0 occurs. Yes, I want to do this. Use your intersection, OSNAP, INT, and snap exactly to where the two center lines cross. Be careful you don't choose this intersection, the edge of the manhole. It's the center line intersection right here. Say OK, and now you'll see the label adjusted. And that's the alignment for Street B. Save your drawing. So that's how you create an alignment. Again, that should be review from CDA. You've done this before. You only did it once. Here you get to practice twice. The next thing you want to do is produce the existing ground. I think this is the last thing. The existing ground profiles, original ground profiles. Okay. Now to do this, and when you're creating profiles, you always want to work in world coordinates, which this is, but you want north straight up. So now I want to rotate the view so north is straight up again. So based on this coordinate system, I'm going to type in plan and hit enter twice. Once to start the command, once to accept the current coordinate system, it's going to rotate so X is horizontal. Right? So now X is horizontal. So you always want to work in world coordinates when you're producing your profiles. Okay, you don't want to remember what angle the profiles are at. You always want them at 0 angle according to true northern and eastern location. Okay, you'll switch back and forth from these rotations again, so you avoid getting that kink in your neck that we talked about. But when you do your profile work, you always want them horizontal to the true easting direction, northern direction. So how do you create a profile? I'll do it again twice for both. Profile. Create a profile from surface. So this creates the existing station elevation list of proposed centerline stations, existing surface elevations. For street A, the original ground surface should already be shortcut into this drawing. Click the add button and that creates the data. Okay, and now you can draw it in the profile view. Change some defaults here. You don't want the standard profile view, you want the road one. This is what we did last year. Okay, and then if you want to, you can skip over to 1, 2, 3, 4, the data bands. Choose the road standard data bands. You can delete the first two, but we'll do it after. And now you can draw this. So here's the profile for street A. Okay, and you can delete the labels. You don't need those for existing ground, and you can change the style of the existing ground to existing road. So again, you're going to pick on it, right click, edit profile properties, change the style to road existing. This will be that red dashed thing we saw last semester. And there's your existing ground. We're not going to use these two bands again, so now we can go back to the profile view properties and go to the bands and delete the top two. I don't want that and I don't want that. Say OK, and it deletes those two bands. So that looks very familiar from last semester, right? What we did in CDA. If you make any mistakes with the styles, okay, don't delete anything and start over. Let me do the next road and not choose any of the styles. See what happens, okay? So I'm going to do this again. I'm going to go to Profiles, Create from Surface. Instead of Street A, we're going to use Street B this time. I'm going to click Add. That'll give me the data I want, okay? And now I'm just going to draw it, and I'm not going to change anything here. I'm just going to accept the defaults. I'm going to say Create the Profile View, and this is what you get, right? Wrong style for the view, wrong style for the existing ground. It's all a mess, okay? So you have a couple of options here. I believe you can match the property. This is the AutoCAD Match Property button. You can take this profile style, this grid, and apply it to this grid. So now the styles are the same. You can delete the labels. Now you can match the styles for the actual profile, not just the grid. Use that same command. Take this style for the existing ground and apply it to this existing ground style. Now they look the same. How do you get the bands? Well, you click on the style, you right click, you go to edit the profile properties, you go to the bands and you go here import band set, the one called road, and here immediately you can delete the first two. Say OK. And now this looks a lot like this. And notice it's much longer, right? Street B is longer than Street A. So there's Street A, Street B, they're ready to go. And that's all you need to do for this assignment. Just have this ready, because in the next assignment, in the next part of the design, we're going to design the profile of the road. Okay? Remember last year, we designed the kind of the green proposed road as opposed to the existing road. So I just want to get this ready so that you can start. Another thing you may want to do, and let me get the view back. right? So I'm going to say UCS from here to here, north, straight up this way. I'm going to type plan and hit enter twice. That rotates the view. UCS, enter, enter. I get true north back. When I draw the plan profile for street A, this is the view. This is the view I want, right? This is the viewport I'm going to be looking at, the plan view of street A. Notice 0 is on this side, and the plan is going to increase from right toward the left. If you look at the profile, 0 is here, 0 is here, and it's increasing from left to right. So the plan is going from right toward the left, increasing, but the profile is going from the left toward the right. It's backwards. So because I want this to be my view for the plan view, I want to mirror this. This isn't going to work for me. I don't want 0 at this end. I want 0 at this end. Everybody understand? We want the chainage of the plan and the chainage of the profile both to increase from right to left. So the profile is left to right at this point. So there's a style for that. I've already programmed it. Let me get the view back so you can see this happen. Plan, enter, enter, rotate back. And then here I want to change the style. So I'm going to right click, I'm going to go to Profile View Properties. And instead of the one called Road, I've got one called Road right to left. These two are actually the same. But the right to left will now flip it so that the 0 is on the right and increasing toward the left. If I say OK, watch what happens. It flips it. Now 0 is here, and it's increasing right to left. So when I my plan and my profile, they're both increasing from the right toward the left. Okay, so that's new. We didn't do that last semester. We did everything left to right. So you can change the style to mirror it. And the only difference between those two styles is this switch right here. Look at the style. Not the property, but the style. All I did was switch this, this button here. All right, so this is the only change. If you look at the properties, the only change between these two styles. I just flipped that switch. So it's exactly the same, just one is left to right, one is right to left. Okay, so please, when you hand in your assignment, make sure that street A is increasing in the profile from the right side toward the left. Get it ready for the plan profile setup later. I'm going to be checking for that, right? So make sure you use the correct style. This one is right to left. Street B is typical, left increasing toward the right. And leave that alone. Why? Because when you look at the plan view, whoops. When you look at the plan view for Street B, this part is increasing from from right to left. But the piece we're detailing is actually increasing. The piece we're going to show, theoretically, is increasing from left toward the right. So this plan view is increasing from left toward the right, which is exactly what the profile is doing. 0 here, increasing from the left toward the right. So leave this one alone. It's typical, but this one has to be switched to go backwards the other way. I think I've touched upon everything you need to be able to produce for next Friday. So you still have almost 2 weeks to finish the exercise. We've got about, we're done at 4:10 today, right? Got about another hour. Why don't we take a 10-minute break? And I hope some of you have been trying some of these techniques, and I'll answer any questions, okay? And again, remember, you can either type or unmute yourself and ask a question verbally, okay? So if there's anything I said today or said in the past couple of classes about how to do something, or you want to see me demonstrate something for this particular submission, we have about an hour or so. Let's take, so it's 3:15, let's say. Let's come back at 3:25. Want to take a 10-minute break? It's been a while. I've been talking a long time. Let's take a 10-minute break. Collect your thoughts. I hope you tried some of this stuff, and if you have any specific questions, I can answer them. Okay. And again, feel free to ask verbally. You can unmute yourself. Okay. So let's take a 10-minute break. Okay, I'm back. About 10 minutes. So are there any questions? Anybody want me to review something I've talked about, or you're not sure what to do or how to proceed with one of the processes or drafting techniques? Remember, you can unmute yourself if you have any questions. Yeah, if you don't want to type, you should be able to ask audio questions. Do we put point style for line valve? No, for the water main, what I would do is I would borrow this. This is all AutoCAD. The only Civil 3D requirement for this part is just the 2 alignments and the 2 profiles and the surface, of course. That was the first thing we did. So for the line valve, you could just borrow from here. Here's the line valve. Make a copy of this, put it on the appropriate layer, and just use it. So just use AutoCAD for all the servicing layout. Okay, Tron? Let's not get too fancy at this point. Okay, the water main, almost in its entirety. How do we connect the pipes from existing Chuchmak? So there's no sanitary or storm on this part of Chuchmak, Street B. Okay, so we're not adding any sanitary, we're not adding any storm here. Hang on, so you don't need to worry about sanitary and storm connecting. So the storm sewer ends here, the sanitary sewer ends here. And where exactly? Well, it depends on where your last service connections are. So probably this one will dictate. So if you had a double here, right, your sanitary manhole would be just on this side here. Oops, not the alignment, sorry, the sanitary manhole. Hang on. So if you take your sanitary pipe and you could put it right here and draw your circle here, 0.75, put it on the right layer. I don't think you can put a service connection into the maintenance hole. I don't think they want that. So there's somebody asked that, Samuel. No, I don't think I saw that anywhere in here. They're always trying to avoid going straight into the manhole. So if you look at any of the dead ends, you'll see they're always avoiding that. They're always connecting to the pipe. So the maintenance hole is only for the main line sewer, not a service connection. So that's a good question. Okay. I don't know if that's written to the standards, but I don't see it anywhere. It looks like they're avoiding that at all costs. Yeah, see here? They're connecting to the pipe, not to the maintenance hole. There is no shared screen. Oh, you can't see. Sorry. Shoot. Sorry. Let me go back and cover that again. I just realized. Thanks for pointing that out. Let me share my screen again. I'm sorry. Application, share screen, entire screen. I'm sorry. I've been talking. You guys can't see anything. Okay, let's go back to this. Right, so there's no sanitary or storm sewer on this piece of Street B. Okay, so we don't have to worry about sanitary and storm here. The sanitary and storm sewer will start short. So if you look at Street A as an example, your service connection, you could have a double here, remember? And draw it better than what I just did, right? Draw it exactly, accurately, the way I did before. But if you put a service connection here, then your last maintenance hole could be here. There's no other sanitary connections beyond that point. And then you might have another double here. So this is the limiting factor. So your maintenance hole should be just on that side of the service connection. Anything longer is a waste of pipe. Okay? So that's the first thing I said. I don't know where to stop the pipes until you know where the service connections. Now the storm, put it nearby, but you won't know where to stop the storm sewer until we lay out the catch basins, which we're not doing yet. Right? So put it somewhere. You could put it near the intersection or not, but until we know where the catch basins are, we won't know where the length of this sewer needs to go. So put it near the sanitary, but certainly this could be here or a little closer. Service connections into maintenance holes, I don't believe are allowed. I can't remember if it's written in the standard or not, but I don't see that happening anywhere on the subdivision. So here's a dead end. You notice the service connection is not to the maintenance hole, it's to the pipe. And I see that throughout, right? Service connection onto the pipe, not the maintenance hole. There's a few of those examples. So do not put a service connection in a maintenance hole. Same thing here, right? You could have gone into the maintenance hole, no, onto the pipe. So maintenance holes are only for the street sewers, the main sewers, not the service connections. Sorry, Samuel. There's the picture to go with what I said earlier. Okay. The other connection, Warren, I'm going to go back to yours, existing Chuchma. The only connection you have to make there is the water main. So if you isolate the proposed and the existing water main, you need to put in a 45 in here. So I would probably draw the line that connects these two for the angle, endpoint to endpoint. Turn everything back on, and you want to put in two 45s, right? Two 45s here, and get rid of the curve. .45 there, and trim this off to here. And remember, this pipe here is copper, but this pipe here is PVC. How do I know that? Well, if I go back to the drawing, we want to make sure that we propose everything that we have to, right? So this, see, is a 50 millimeter water main. This is copper. This is all copper all the way to this point here. Okay. So this is PVC pipe up to here. So you can ignore all of this because it's copper. And then if you have that there, you might even be able to connect to it. I'm not sure. Right? So there's that piece here. So if you're going to put your 45-degree bend there, then you need to propose from here to this end of the pipe a plastic PVC water main, right? Because this is where the PVC ends. This label's in the way. Here's the pipe. This is plastic on this side. This is all copper on this side. So if you're going to put your bend here, you have to propose a plastic piece to connect to where this one ends. Okay. But again, you can put this wherever you want, right? So maybe you can connect it right there, right? And not have to put in any other piece and then fillet this, right? And put your 245. Replace the plug with a 45 and put a 45 here. You've got a lot of flexibility here, except I don't want to disturb this maintenance hole. So that's not going to be a good solution. So maybe what I did before was better, right? So be mindful of your existing condition, right? So make sure you keep away from here. One thing you want to be mindful of is water main is very sensitive. They don't want to contaminate the pipe, especially with sanitary flow. You don't want the, your house drain, all that stuff from your toilets and your sinks to contaminate the drinking water, right? We don't want to cross-contaminate. You'll find there's a requirement, and I believe it's in the standard. This is worth reviewing. In the Richmond Hill here, sorry, the region of Halton, you're going to see a clearance. I believe it's here. Separation from storm and wastewater, storm sewer and sanitary sewer. You must be laterally, that means in the plan view, 2.5 meters away. So if you're a water main, sanitary and storm must stay away from you by at least 2.5 meters. And there's the standard that tells you that. So what does that mean? And usually most people interpret that as the center of the pipe or the center of the structure. So if I draw a circle from the center of the structure, 2.5 radius, the water main has to be out of this zone. So that's no good. So you might have to move this further out to satisfy that condition. Right? And now the water main is 2.5 meters away from the center line of the structure. Some people will interpret it from the edge of the structure. So if you know the size of the structure, you offset 2.5. If that's drawn to the correct radius, you might have to stay out of this zone. Okay? So it depends on how you interpret it. Usually it's the center of the structure, center of the pipe. And you'll notice the distance from the typical position of the sanitary to the typical position of the water main is more than 2.5. That's by design based on that standard we just looked at. So be careful. Make sure you keep away. If you're a water main, make sure that everything is away from you by at least 2.5 meters. And that's what I mean here, right? Once you decide where your sanitary maintenance hole needs to be, right? If you're going to extend your sanitary sewer and put a maintenance hole here, right? If you're going to put a maintenance hole here, right? You could bring it closer. Right? You could bring it all the way up to here. Remember, you want to connect the service connection to the pipe, not the structure. Once you know where that is, then maybe you offset or you draw a circle from the center, 2.5, and now the water main. Remember, we tried to draw the water main kind of at this direction. You want to make sure that that is away out of that zone. So maybe that's where your pipe goes. not the curve, right? So now it's to stay away from this by at least 2.5 meters, center to center, right? So you won't know where to put this until you know where this goes, and you won't know where to put this until you've designed where this goes. So see how you have to kind of do one thing first, and then the next thing, and then the next thing, and the next thing. So we laid out the sanitary pipe, but we didn't know where to stop it. Now that we have the service connection, we know where to stop the manhole, and now that we know where the manhole is, we know where to put the water main. Okay, so it all kind of depends, one thing after another after another. At the end of the day, your design has to satisfy all the standards. So as you're creating your design, and the more and more detail you add, the more and more things you need to be mindful of. So be careful, right? What you did before may have to be revisited, right? And until you get everything you need, you might not be able to check it, right? So you wouldn't know where to put the maintenance hole until you see that. First we put the pipe in. Then we decided where the service connection goes. Then we can shorten the pipe, put the maintenance hole nearby, and then look at where the water main needs to go in relation to it, right? So you couldn't, even though you laid stuff out already, you're kind of tweaking it all the time. And most of the time, just like in CDA, most of your effort is going to be zoomed in on the corners. What's happening at the corners and what's happening at the intersection. Those are the parts that kind of need your detailed attention. What happens between the corners and the intersections is kind of very typical for the most part. So you kind of do it, and you can kind of, it works itself out according to the standard. But once you get into the corners and the intersections, then you really have to think about, okay, how am I going to do this now? I'm still not sure about the position of the hydrants. Is it 3.5 from the right-of-way? No, this is, remember, both of these roads are 16-meter right-of-ways, and we're using standard E2, so it looks like this. We're looking at this drawing here, E2. This one, E2. So to locate the center of the hydrant, you go 2.6 meters from the right-of-way, right? This is the street line here. So back to the drawing, 2.6. So where do the hydrants go? We're going to offset 2.6 from the street line. And now your hydrant can be anywhere on that line, right? Remember, stay on the same side of center as the water. If the water main's on this side, the hydrant's on the same side of center. So your hydrant can be anywhere on that line. But you can't put it in the middle of a driveway. You can't put it on top of a sanitary connection. You can't put it on top of a water connection. So don't lay out your hydrants until you have your driveways, your sanitary, and your water connections all laid out. Right? So if you look at this, you have to lay out all your driveways. You have to lay out all your sanitary connections. You have to lay out all your water connections. And then you'll see spaces of where you can put your hydrant. And look at these hydrants. See this hydrant? Hydrant, right, had a home right in here where there's no driveway and there's no water connection, right? So this is not by mistake. This was decided to be placed here after all the driveways, after all the water connections, after all the sanitary connections. Okay, but the distance from the hydrant to the right-of-way, that's in the cross-section, right? And remember this is a 20-meter right-of-way. The distance from here, perpendicular to this street line, is 20 meters. So if I check this out, the distance from the center of the hydrant perpendicular to the street line, it says is 3.4. That's different. Well, it's a different cross-section. Let's look at the standard, right? What did we say? 3.4? 3.4. You want to see where the 3.4 comes from? We look at the standard for a 20-meter right-of-way, which is E3, 20-meter right-of-way. Where's the hydrant? 3.4. Ours is not 3.4. Ours is 2.6 because we're not looking at E2, E3, we're looking at E2. See, does that answer your question? The layer for edge of pavement and the standard is not green. Is there a mistake? No, I can't remember what the color is. Whatever the standard, if it's in the standard, use the color, whatever it is. I think it's I'm not sure if it's green. In the standard is gray for the edge of pavement. Are you talking about this standard? Whoops, you're talking about this layer standards, this one here? So back of curb is 8. Yeah, so make it 8. It's gray and make it dashed. Yeah, you can use this as a guide for sure. This isn't complete, but it gives you most of what you need. How much is the allowance to connect the pipes in Street A to Ledger Way? You're talking about this? How do we get this connected to here? And how do we get the sanitary connected to here? I'm going to leave it up to you. Do something. Okay? Do something. Let's see what you got. It's time to shine. Okay? If I always tell you the answer, you're never going to think for yourself. So as long as this pipe is connected to this pipe, it will work. But there are some solutions that are maybe more elegant than others. Okay? But from a plumbing perspective, as long as you make the connection, the water will flow, the sanitary will flow, the water main will provide. There's more than one way of doing it. I want to see what you want to do. Okay, so show me what you're thinking, and if it's as long as you make the connection, I'm happy. But some solutions are a little more elegant than others. Okay? I'll leave that alone. The only thing, like I said before, if I offset 3 meters, the edge of pavement, which is this line here, this is the back of curb, make sure you leave these pipes alone inside this zone, right? We don't want to disturb the existing asphalt. So you can trim the pipe up to here, or you can make it longer. You can make this longer if you want. You can make it longer, or you can trim it up to here, this 3 meter zone, right? This is 3 meters away from the edge of pavement here. Okay, but I don't want you to rotate the pipe, right? So don't rotate this. In order to rotate the pipe, you need to dig up all the existing asphalt on the road. We don't want to do that. So you can make this pipe longer, or you can make it as short as this 3 meter mark, from the edge of pavement here, right? So that's as short as it can get. You can make it as long as you want, and you decide. But try and keep the connection as close to the intersection as possible. Keep these pipes in the standard position for as long as possible. So the short answer is I'm not going to tell you. You tell me. But there's some suggestions and some guidelines. Warren, I hope that gives you a uneasy feeling. And that's what you're up against. How am I going to solve this? Well, you're the designer now. Do something. I'm sure everyone's going to make the connection, but again, some solutions will be more elegant than others. And after the submission, I'll demonstrate 1 or 2 of the ways I would do it. And again, there's no wrong answers, but there's no wrong solutions, but there are some solutions that are better than others, right? But as long as you make the connection, I'm going to be satisfied. That's all you need to do. Okay, but then I will discuss what I might do. And I might find some ideas that you guys come up with that I've never considered. So I might learn something too. So don't be intimidated, right? Just do what you think, and then we'll discuss it after. Okay, and this is another thing when it comes to designing. When I was working, one of the first things I learned from one of the mentors that I was dealing with, when I was tasked to do something, and I wasn't sure how it should be done, I went to him once and I asked, okay, how do you do this? And he sent me away. He said, show me what you think you should do. And he would ask me to come with an idea or a solution in mind, and then he would discuss it with me. So when you're designing these things, don't ever ask a question about something you haven't tried yet. Okay, and this is one way of gaining the respect of the people that are going to be supervising you. If you're not sure how to proceed, do something. Right? You've got some ideas now. Do something, and then go and discuss it. Say, here, the task was make these service connections. How I think I would do it, and then go and talk to somebody who's got more experience. Say, okay, how would you do it? You know, does this make sense? Would you do something different? Did I miss something? And then they're more likely to come and have that discussion with you. Oh, okay, so I see what you're thinking, but did you think about this? Or maybe you missed that. Or the answer might be, yeah, that'll work. Do it that way, right? So you never know. But if you show up with a blank piece of paper and say, how do you do it? You're not going to gain a lot of respect. Okay, so you really need to make an attempt before you start a discussion on, hey, you know, does this make sense? Okay, if there's nothing to discuss, then they really won't want to deal with you. So you really have to make an effort first, and then you can start a discussion about maybe, you know, is there anything missing? Is there something wrong? Could it be better? How could it be better? And that's how you start to gain the respect of your colleagues, especially the people that are going to be supervising. Okay. The worst thing you can do is call the municipality. How do you want me to do this? Well, they're reviewing it. They're not designing it. So they're going to look at your design and tell you whether they're going to accept it or not. It's not their job to design it. It's their job to review it and make sure you followed all the standards. They may have a suggestion on how they prefer you do it, even if it's not in the standard. And then, you have to make a decision about whether you're going to change it or not. But generally speaking, they have the last word, but they review. They don't suggest how. They want to see what you're thinking, and then they'll tell you yes or no. And they may or may not give you a suggestion on what to do, even though they don't accept it. Okay, so at the end of the day, the design really falls squarely on the shoulders of the designer, ultimately the review engineer, right? So if your career kind of goes into a technician technology level and you're not the engineer signing off on it, ultimately you have to satisfy the engineer. So they'll review it before it goes for final submission and review by the municipality, but certainly you'll have to take some responsibility. So you need to show some initiative and make an attempt before you kind of start to ask questions about what the best solution might be. Okay, I hope I'm not going on too much, but that was my experience. When I showed up with a blank piece of paper, they say, well, there's nothing to discuss. What are you thinking? Obviously nothing, so they didn't want to talk to me. And that was one of my first experiences, so I learned very quickly. If I have a question, I better have a solution in mind before I approach anybody. Any other questions? So really, I've covered everything you need to know about this first submission. I believe it's next Friday, right? The date is next Friday. Yeah, Friday at midnight. So the 12th is next week. Oh, the 12th is 2 weeks from now. Is that correct? Digital code must be submitted by the 12th. I thought it was next week. I think this is wrong. I think this might be the wrong document I'm showing you. Let me see what was downloaded. I might have the wrong document. I believe it's next week. There is no February 12th. Oh, there is. Okay, let me just check. Let me confirm the date. I've got it. It's in the course web page. Let me check. Hang on a second. Should be in the addendum. Pretty sure we settled on week 4. Yeah, week 4. It's due next week. It's due next week, week 4. So that was right. And I remember we changed it this year. So we need to go to not assignments, course documents. First submission requirements. Yeah, it's next Friday. I was showing you the wrong document. Okay, yeah, it's due next Friday. I was right. I was probably using last year's document. Everybody get that? It's due next Friday. Okay? I'm going to send a reminder. I will post a place to submit everything. Basically, I want your 2 drawings, your topo DWG and your base DWG. And I'll be able to mark that. And I'll do you'll see that the procedure is very similar to what we did in CDA. I'll email you a detailed rubric of what the marking scheme is and what you earned on each one. Okay? And it's pretty much going to be the same. Did you do it? Did you do it correctly? Did it make sense? You either got the mark or you didn't. Okay, so please follow the instructions carefully. If you're asked to dimension something, if you're asked to label something, make sure that's all included. If you're asked to label something typical, don't label it everywhere, right? Keep it clean. Make sure you complete everything, don't leave anything blank. If there's any, like if I ask you to do the lot servicing and you miss 1 or 2 lots, then that's going to be wrong, right? If there's no water for one house, then there's a problem. If there's no sanitary connection for one house, then it's a problem. February 5th, yeah, that's correct. Okay, so the document that you downloaded is February 5th, not the 12th. I was showing you last year's file. Sorry. Yeah, I'll create that. Are you ready to submit, Sumitra? Sumitra, are you done? Okay, yeah, I'll have that ready this week for sure. But it's due next Friday, almost 2 weeks from now. Any other questions? Any other things you want me to review, or is there something maybe you didn't get or I missed? So you're talking about the units for meters, like the M for meters? Okay, let me see if I can do that. So if we go to, okay. Can you see my screen? My AutoCAD screen, sorry. Can you see my AutoCAD screen? Okay, so if we go to dimension something, suppose I'm going to put a dimension here, align, whoops, dim, align. So I'm going to go from here to here, and there it is, okay? If you want to add M for meters to that, you would change it, CH for change properties, click on it. And so if you want to add M for meters, there's a couple of ways of doing it. One, you could edit that one, or you could change the dimension style. If you type in dimension, DDIM, you can go to that style and modify. And then if you want for text, you can actually add, I think it's in here, you can add the units, suffix, put an M there. And then every time you create that, the M shows up. So that's one way, DDIM, and go to modify, and then go to the primary units and add the prefix or the suffix there, M for meters. Okay, so every time there's a dimension, it always adds an M on the end. That's one way of doing it. I'm going to delete that. If you only want to do it once, you can do it here. If you go to the properties and you click on it, if you go to where it says text, you'll see here, that's the dimension, and it's dynamic, right? So if you change this, the text changes, right? 1003, 1003 right here. If you want to add it to just one occurrence, then you can do a text override. But if you don't want to lose the value 1310, you put in less than, greater than symbol, and then you put an M on the end. So the less than, greater than will continue to read the distance and put the text for the distance in, and then it'll add an M to the end. So it'll look like that. So now if you move it, you see the text still changes, but the M is always there. So this technique is if you want to add M to the one. If you want to always have an M, then use the other technique, right? Which is to say, again, take this, get rid of this, right? So if you want to always have the M, you change the dimension style. And you go to modify, and you change the primary units, add the M here. And then every time you create it, you'll see actually a preview here, everything has an M. But be careful now, if you do an angle, it'll put an M there too. See that? That's a problem. So you might want to be careful about that one. But if it's all just linear, right, even the radius here is good, but not the angle. So be careful, okay? So there's a couple of things to watch out for. Okay. Then the size of the arrow you could change as well, right? That's DDIM. Change the text to change the arrow size. So if you want the arrows to be a little bigger, you can change them here. So instead of 0.5, make them 1. Say OK. Whoops. Say OK. And you should see those arrows get bigger. Say OK. And now the arrow's bigger, and so on. The text height. The height of the text. For dimensions, remember I said the standard text height is 2 or 1, right? L80 at 1. You can't change it here. You can't change it here. And you can't really change it here unless you create the style, right? So if you want to make the text for the dimensions a little bit smaller, remember instead of 1, you can use 3/4 or 0.75. You can actually do this. Whoops. You can actually do type in style. This is a text style now, style. So L80 is a height of 1. We can create a new one, right? We can create a new one. Call it L60, 3/4 of 80. Make sure that it's simplex, change the height to 0.75, and now you have a new style called L60 with a height of 0.75. Close this, and now if you go to your dim style, DDIM, and you go to modify, and you go to your text, you can swap out the height. So instead of 1, remember you don't have control over this, you can use the L60, and it'll pick up the 0.75. And now when you close this, this will get a little bit smaller, right? 3/4. And now the arrows look too big, so I might change the arrow size down a little bit. So for dimensions, I think it's cleaner if you have a little bit smaller, not the standard 1 meter, which will give you 2 millimeters in paper, but 3/4 that. Okay, 1 will work, that's typical, but again, if you need to squeeze a lot of stuff in, you might want to, reduce it by about a quarter, so 3/4 height. So instead of 1 meter standard, use 0.75. Okay. Make sure there's no overlap. Keep it clean. You don't want text on top of text if you can avoid it, so that everything's nice and legible. It's okay to have text through a line, right? It's okay to have a text through a line. Right? This text goes through this line, that's fine, but you don't want text on top of text. So when you start labeling stuff, make sure there's no overlap of text. It's hard to read. Okay, so keep that in mind as well from a kind of best practice in drafting, right? You want to keep it clean. You want to make sure everything's legible. Any other questions? I did post my office hours for this group, right? So I have some time. I think I sent out an email. If you want to meet with me to discuss something specific about your layout, your design, send me an email, and I'll email you a meeting request, and we'll schedule the time for one of those two. I think the time was either, I think just before class on Tuesday or Friday at 12:30, I believe. So I set an hour aside for this group before class on Tuesday and midday on Friday. But anyway, just send me a request. Hey, I want to meet. Can we discuss my design? And I'll send you a meeting request. Okay, and then you'll be able to share screens. I can look at your screen, and usually through that, I use MS Teams. Usually I'm able to take over your screen. So you can show me your CAD file, and then I'm able to ask permission to go in there and do stuff. So I can actually show you on your drawing how to do something, if it's simple enough, if it's something that you want to see demonstrated in your specific case. So we've done that in the past with other students. Any other questions? Okay, so there's plenty of time to complete all of this. There's a lot of work to do, okay, but it's not terribly difficult in terms of very repetitive, right? Service connections, you can make copies of once you get it. Driveways you can make copies of, but again, pay attention to those special parts, right? The intersections and the corners. Review, always review. If you're not sure how to do something or how it should be done, always look at what the previous design has. And this will give you some insight and some clues on how you can lay out your stuff. A couple of things I don't like about this drafting, again, is the driveway hatching going through the sidewalk, right? There's a sidewalk here, right? Here's the sidewalk between this line and this line. The hatch shouldn't go through the sidewalk, so please don't do that. It's misleading. The other thing that they do that I didn't like was the naming of the bends, right? Instead of 90, 45, 22.5, 11.25 degree bends, they're using quarter, eighth, 16ths, and 32nds. It's kind of confusing, so please don't do that. Otherwise, the way they're showing their stuff is pretty good. Do not label sanitary sewers and storm sewers, okay? I just want to see the schematic. Where are the maintenance holes and where are the pipes for sand and storm? Water main you can label, right? You can label the water main, 150 PVC, ours are 200, right? To label the water main. Label the sidewalk, label the radii, right? All the curb radii. How do we number the maintenance holes? Don't worry about that now. We'll discuss that when we do the pipe, when we digitize the pipes for the servicing. Okay. You'll notice they're labeling it a little different than us, right? They're actually doing it backwards to what I taught you. Remember what I said? The last place where all the flow accumulates should be manhole 1 or maintenance hole 1. You'll see they did it backwards. See this here? 181. This is 81. This is 80. Okay, so they're counting. The numbers are getting bigger as they go toward the end of the pipe. That's not what I taught you. I said use the lowest number at the outlet and work your way upstream, which is what I want you to do. Okay, we'll discuss that later. But don't worry about the maintenance hole. Don't put any label, no text for sand and storm at this point. I just want to see your layout. Okay, the only thing you need to be mindful of is the direction, where the outlet is. Okay, so just like in CDA, we're going to trace those pipes with the pipe network database, and then we'll label everything. We'll discuss that at that point. Okay, so right now we're just in a preliminary stage for the pipe layout. Water main, you can put a label. That's fine. And when you decide on what size, this is how you label, right? You draw it. So if it's the rectangular one, draw it. Use the inside dimensions. And then you don't need to worry about the number. Don't number them, right? Just type in VC, the standard, and the standard is either going to be 400.02 or 400.01 if you're using the round one. And then put the T size. And the T size is going to be 200 by 200 because all our pipes are 200 Ts, right? So they want to know the size of the sewer going through, or sorry, the water main going through, and they want to know the leg at 90 degrees. So this is a 300 pipe, and this is a 200 pipe. So the T is a 3 by 200. So use this text style. Don't include the number. I don't need to see the number, right? So just VC standard and then the T size. And make sure you draw it. If you're using 401, it's round. If you're using 402, it's rectangle. Okay, so at least draw it schematically. There are others, like that one's 401. This is 402 is the rectangle. 402 is the rectangle, but there are some round ones in the site. This is also 402. Let's see if I can find 402. You'll find a round one somewhere. There's a few. 402. Here's a round one. Here's the 401. There's round. Okay, so make sure you label it correctly. Don't number them though, just VC, standard, and then the T. And separate everything, right? The object has one layer. The text for that object is a different layer, right? So pipe text. Maintenance hole text, but that'll take care of itself later. Catch basin text, and so on. We'll get into all that. Because if you want to show just the line work without any of the text, you want the text on a different layer than the object. So everything you see here has a layer, and all the labels has a layer. You should see two layers, the object and then the text for the object. Okay, so Trong, just to get back to your question, the maintenance hole numbering, we'll deal with that later. Any other questions? Could you show us how to parallel the labels with the line? Yeah, I could do that. So if we had text, dtext, 45, actually I'll show you a couple things. If you take a piece of text from anywhere, change the style to L80 if you want to use L80. So change the style to L80, then it'll be a height of 1. Right? It's a height of 1. If you want it smaller, change the text to L60. If you created it, it'll get a little bit smaller, 0.75. Okay. If you want to label the bends, You want to label the bends. Okay. If this, and I would change it, if this has a rotation of 0, I would start with that. And now this is parallel to the x-axis, right? If you look at your icon, right? This has a rotation angle of 0. It's east, right? It's east. It's parallel to the x. So change the rotation angle to 0. And then what I do is I take the text, I take any of the grips, I put it on the line, and then I rotate. Whoops, then I take that grip, grab it here, and I hit enter. This is a grip edit, so see it says stretch right now. I hit enter, move, I hit enter again, rotate. So now I can rotate, and if I'm in world coordinates, I'm parallel to the x-axis. So now I can snap here, near, and it's parallel to this line. So always start with 0. Put the insertion point on the object you want to align. So say I want to align it to the sidewalk, and then clamp, touch it, click here, click in the grip, and then cycle through the different commands. Not stretch, not move, rotate, and then snap, and now it's parallel to the line. Does that help, Claire? Okay, and then if you want to do the two 45-degree bends, right, if you want to take that, copy, I'll put it here. You can paste in the text, right, 245-degree bend. The degree symbol, if you want the little degree symbol, there's a code for it in the D text. It's %, D, I believe. Okay, so if you look at this, you'll see here, there's the code for it, % D. That code will show up as a degree symbol. There's others. If you want it to be the diameter symbol, instead of % D, it's % C. Now it looks like a diameter symbol. So there's a whole bunch of codes, right? But those are the two more popular ones. If you use % P, P as in Peter, if I put a P in there, it'll come up as the ± symbol. See that? So there's different code numbers for more unique symbols. The one you want for degree is % D. You need the % D. And if you're going to use the 2 by, I would use a lowercase x. I would use a lowercase x, and I would get rid of the spaces, make it nice and tight. And if there's 2 of them, it's bends. Again, we're getting real picky now. Bends. Or you can have 45-degree bend, 45-degree bend. You could have a label at each point, one here and one here. You can have one label for both. Okay, so those are just AutoCAD tips and tricks, stuff maybe you didn't learn yet, or nobody explained to you, or whatever you like. Just a few extra items. You didn't learn any of those % symbols, % codes? I think you can Google them. It'll give you a list. Only a few. Yeah, from me. Well, I'm no genius. I don't know all of them. There's a lot. Sometimes if you go to the internet, you might see some forums or some discussions about it. So if you go to AutoCAD text codes for symbols, you might see a list. Right, so % D, % P, % C. These are the 3 I remember, right? But then there's others, right? If you want the center line, you know the center line symbol? It's U. It's this code here. Anyway, there's a whole bunch here. Some of them I never use because I don't do this kind of stuff. Anyway, that's where I learned most of this stuff. The delta symbol, you know, for deflection angle, it's right there. Yeah. No matter how much you know, somebody else always knows more, right? And the nice thing about the internet is there's a lot of information there, right? I don't know everything, but sometimes you don't need to know everything. You just need to know where to look for everything. And there's a lot of stuff online. So if you're not sure, you could always Google it. Well, that's it for today. I think we're done. I'll see you next Monday. So please, what I suggest is have your assignment that's due next Friday ready on Monday, or at least close to finished on Monday. And then if you have any last minute questions, I can help you out. Okay, so you may not have a question to ask me unless you've tried the exercises. Okay, so you may have questions later. It's certainly between now and next Monday or next Tuesday, you can ask me or email me, and I'll do my best to get back to you. But if you should be, remember the due date is not the day you do the work, right? That's the day you submit it. So always be ready ahead of time. You shouldn't be late. Please don't be late. That's bad form, not just for me, but in general. If you make a promise or a commitment to a client, you need to see it through. So I expect you to be on time. And next week we will start to cover the stuff for the following submission 2. Okay, but I will answer any questions between now and then. That's it for today. I'll see you next week. Thank you, everybody. I'll see you next time.